Yeah, we aren't going to do growth and decay. We're going to do lesson algebra, lesson 9.8. And like I said, this looks, well, it's geometric sequences as exponential functions. It looks complicateder than it really is. Yeah, complicateder. You know what I mean, right? Why speak perfectly when I can speak the way I want to and have you still completely understand what I'm talking about? You do not need graph paper today. All right. See, I is cool, where you is not. That's right. I be understanding this. Okay, anyway. Here's the deal. Do you remember when we did this? Well, you should remember an error. Okay, I did bring this up at one point in like chapter 2 or 3, I think it was. And it didn't probably register with you that, you know, we're about to compare it to something. Here's this. If I have 20, 15, 10, 5, ... This sequence is called arithmetic. Everybody say arithmetic. It looks like arithmetic, but it's arithmetic. It depends on, you know, just like the word read, you know, how do you say that word? Read or read, right? It depends on how it's used as to whether or not it's read or it's read. If you look at this, what is that word? It's arithmetic or it's arithmetic. Does that make sense? Depending on how it's used. Anyway, this sequence is arithmetic. Here's the reason why. It's because when you go from here, how does the 20 go? The 20 goes to 15, which is minus 5. This is minus 5. This is minus 5. It is consistent. Agreed? It's consistent. And it's a consistent addition problem. Oh, be careful. Even though it looks like subtraction problem, it's an addition problem. Do we all remember that? Subtraction is just addition. How is this addition? Explain it. It's a plus or minus 5, right? Does that make sense? This is plus negative 5 each time. Okay, so it's arithmetic because it's consistent and it's addition. Could you then tell me what's the next 3 terms? What would they be? 0, negative 5, negative 10. You all get that, right? This is something you've been doing since like 6th grade. What if I have this problem, though? What if I have this? 3, 9, 27, 81. Now, here's the deal. If we did this before, and I went like this, okay, this is plus 6. Ooh, this is plus 18. This one is plus, oh boy, 54. And, okay, you go, wait a second. Oh, yeah, is this consistent? Not at all. So then here's the very simple thing. When you're dealing with the addition, if it's not consistent, then all this tells you is that it's not arithmetic, right? It's not arithmetic. It's no big deal. I mean, like, it could be something else. In fact, in this situation, can you tell me what's happened here? It's been multiplied by 3, right? This is times 3, times 3, times 3. Is that consistent? I mean, is it the same thing across the board? Yes, it is consistent. And since it's a multiplication consistent, that is called geometric. Okay? So this is something you have to memorize. You just have to memorize that. Arithmetic, you're talking about addition. Geometric, you're talking about multiplication. What about this? Tell me if this is, no, we'll do it. We'll start with this. 200, 100, 50, 25. Always start with the arithmetic, right? With the adding. From here to here, it goes minus 100, right? From here to here, minus 50. So instantly, we could stop here. Why? It's clearly not arithmetic, right? It's clearly not arithmetic. Okay, so you don't have to erase that. You can just start again. To go from 200 to 100, it could be divided by 2, right? Divided by 2. And then to go from 100 to 50 is also divided by 2. And to go from 50 to 25 is divided by 2. Ooh, consistent? Is it consistent? Yes. Is it a multiplication problem? How would you do divided by 2 as a multiplication problem? Multiply by 1/2, right? Divide by 2 and multiply by 1/2, same exact thing. So that's why I wouldn't do divided by 2. I really wouldn't. I mean, you need to get in the habit of, this is actually times 1/2, times 1/2, times 1/2. Does that make sense? Consistently multiplied, therefore that makes this geometric. It's that simple. Does that make sense? Test arithmetic first. Ooh, not consistent, fine. Test geometric. Now, what if I give you this? What if I have this? Let's see. First thing we do is test for arithmetic. This is plus 5. This is plus 7. Clearly not arithmetic. Okay, not arithmetic. What would this be? Can 4 be multiplied and make it to be 9? Absolutely. No question. 4 times what would be 9? Does anybody know? 2 and a quarter. It would be times 2 and a fourth. And so then you go like this. Ooh, and this is where you just have to be, what is 9 times 2 and a fourth? Well, we know what do we know just without even doing it? 9 times 2 and a fourth is going to be more than 18, right? 9 times 2 is 18. So then it clearly, that's not true. So then this is, again, it's not times 2 and a fourth. So what does that tell you? That it's not arithmetic or it's not consistent. So that means it's not arithmetic or geometric. Does that make sense? It tells you that. And so, yes, right now, that's all we're going to deal with. There's actually another one that we'll eventually get to that's called exponential. Okay? And so then this guy here could be exponential. I'm not going to show you that yet, but there is a third one that the pattern could be. But for today, all we're doing is arithmetic, geometric, or neither. Make sense? Okay. So I think you guys have that part down. That's not a problem. The other part of this assignment that you're going to need to know is this. I need to start using terms. I didn't use that before. Okay. So we're going to go like this. We're going to go 3, 6, 12, 24, ... Okay. Is this arithmetic? What's arithmetic mean again? That it's consistently addition, right? Consistent addition. This is plus 3. This is plus 6. We can be done. Not true. Is this geometric? This would be, if it was geometric, you'd go, how does the 3 become a 6? Times 2. This would be times 2. Ooh, this is times 2. Boom. We have it consistent. It's consistently multiplied. Therefore, it's geometric, right? You need to know this right here. This guy here, what is being done consistently is called the common ratio. You need to know that. That's called the common ratio. I'd write that down. That's important for what I'm about to teach you. Whatever is happening, whatever is going on, whatever it's being multiplied by consistently is the common ratio. So really, the common ratio is just 2. Does that make sense? That's the common ratio is 2. Because no matter what we say, when we say it's a common ratio, it's telling you that it's consistent, and you know it's consistently being multiplied, so then the ratio is just the number. Make sense? Okay. So then, let's do this. Let me go like this. 3, 6, 12, 24, ... Okay. What if I wanted you to tell me what was the 30th term? Oh, that's probably too big for this. That would get humongous. We'll go the 15th term. And so all of a sudden you go, oh boy, this is going to get ugly. Agreed? This is going to get ugly? So here's the deal. What could you do if you had to? In fact, I had a girl, I think I told you this, Alyssa Guevara. Do you guys remember Alyssa Guevara? No. Was she too old for you guys? Yeah. Andrew's sister, right? She, I set it up a question like this, and I said the 50th term. And you know what she did? She forgot how to do it. So what do you think she did? On the back of the page, she actually went and did times 50. She got the answer right. So what I do now is I give ones that are gigantic, and I say like the 81st term. And you know what? If you're willing to do that on the back, good luck. You know what I'm saying? Have a good time spending that 20 minutes doing that. You know what I'm saying? It was a test. It was on a test. She got it right. She forgot the formula. I'm about to give you the formula, okay? The formula goes like this. You're going to want to write this down. It's a to the n. Ooh, what does a to the n mean? Yeah, we'll see. A to the n equals a to the first r n minus 1. Oh boy, look at that guy. A to the n equals a to the first, or a1, r, and then to the n minus 1.
Wait, it's the a up?
What?
The a is up.
A is not up. Yeah, this is just like it is. I'll show you. Look on page 580 at the top. Look at the top of page 580. They give you the formula. I mean, like I wrote it, but you want to see it written a little more neat than me, then there it is. Okay, there's the formula on the page, top of page 580. Look at page 580 there. Kermit, look at 580. Are you there? The formula is in the upper left corner. Now, anytime you're given a formula, what should you say? You should say, thank you for giving me the formula, because now all I have to do is what? Plug stuff in. I mean, a formula is your friend, for real. Like, you're like, thank you for having a formula here. Otherwise, what would you have to do again? You'd have to use the back of your test page and write out all 15 of these. Would that be a lot of fun?
Yeah.
It would? Yeah. Wow, okay. Anyway, it wouldn't. But anyway, so there's this. Okay, let's do it then. Let's plug it in. A to the n. That is the n is the one I'm looking for. It's the term I'm looking for. Does that make sense? The n is the one I'm looking for. So what am I looking for? I'm looking for the 15th term. So it's going to go A15 equals. In other words, that's the number I'm looking for, the 15th term. A15 equals. What is A1? What is A1? What is that? That's the first term. What's the first term? 3. So it goes 3 in parentheses times, what's R?
The ratio.
The ratio, the common ratio. What did we decide was the ratio here? It was times 2 times 2 times 2, which means the ratio is 2. Does that make sense? It's the common ratio. Times 2 to the, n. What was n again? 15 minus 1. Okay, so then let's do this. A15 equals, what is 15 minus 1? 14. So, what is 2 to the 14th power? Oh, that's such a mess. Right? That's a mess. What? Right. You would use your calculator, right? Times 3. Do they not give them that quite so big? I say the 9th term. Yeah, it's a mess. Yeah. What is 2 times 2 times 2 times 2? Does anybody have that one down? What is 2 to the 14th? 16384. 16384 times 3 is 49,000 what? Yeah, buddy. How would you like to do that on the back of your page 15 times or 81 times? Because that's what I give you. That's the type of question I give you. A? It's nothing. You have to have something. I could have chosen the smiley face if I wanted. Yep. Okay. Let me give you another one. I'll give you one that they give me here. Let's do. Okay, here we go. Now this is going to be weird. We're going to see if you can do it. Fine. What I want is the 7th term. Okay, use the formula. I want the 7th term. You're just watching. Usually on the test, I'll tell you, what's the common ratio. If I ask you to tell me what the common ratio is, what is that implying? That there is a common ratio, which implies that it's geometric. Does that make sense? Okay. What I might do is I might say, okay, tell me if this is arithmetic, geometric, whatever, and then, but I can't do that, right? I mean, if I say give me the common ratio, that means there's a common ratio. Anyway, to go from -1 to 5, that would be times -5, and 5 times -5, they're consistent, so then the common ratio would be -5. The formula goes a to the, what term am I looking for? 7 equals, A1, which is -1's the first term, times -5 times 7 minus 1. Not times 7 minus 1, to the 7 minus 1 power, which is 6. So I'm going to change that to a 6th power here. Now I have to go, why is it -1 times -5 first? No. So then, what is -5 to the 6th power? Is it negative 15,625? Isn't that what it is? If you don't know how to do it on your calculator, what can you do here? You just go, okay, you go negative 5, and you can just start crossing them off, right? There are how many of them? Right, this is where you could use your calculator and go negative 5 times negative 5 is 25. 25 times negative 5 is negative 125. Negative 125. You see what I'm saying? You could do that. Just make sure you cross them out each time. Whatever. You should learn how to use it. Do it on your calculator, though. It'll be way easier. What was the answer finally? Which is times negative 1. 15,625 is my answer. How many of you got that? Does it make sense? Does it make sense? One question I have, and maybe you scientists can explain this to me. Look at the bottom left of page 580. Look at 580, the bottom left. Talking about basketball. And then if I take the basketball, look up here now. I take the basketball and I bounce the basketball. I just let it drop. That the ball is going to bounce up to about 80% of where it started. Does that make sense? So if I drop it from here, when it bounces, it's going to come up to about here. And the next time it drops, it's going to come up to about here. The next time it goes down, it's going to come up to about here. Does that make sense? Each bounce is going to come up 80% from the previous bounce. So, but I have a question. If that's true, and I drop it, and it comes up to here, then it comes up to here, then it comes up to here. And eventually, what happens to that ball? It can't stop. Wouldn't it still be bouncing? Wouldn't it still be minusculely bouncing? Do you understand what I'm saying? Like as it gets closer, eventually it stops, but shouldn't it still be bouncing? So then what is I don't know. I'm not a scientist. What is the explanation? I mean, if each bounce, it should still continually be vibrating on the ground. Just they're vibrating. But it doesn't. Yep. Well, that's what caused it to bounce in the first place.
Oh, right. The friction with the ground stops it then?
Is that true? I don't know. I'm asking. I have no idea. I just, like you'd say this isn't consistent though, because it can't be, because eventually it stops. If it was consistent, it would continually be getting smaller, 80%, 80%, and it would sit there and just be vibrating. Maybe it is, we just can't see it.
The friction stops the motion of the basketball.
Good job, Don.
My point is though that then it wouldn't be consistent because it's just not doing 80% anymore. Does that make sense? Anyway. Doesn't matter. I think you guys have this now. I think you have it. I don't see why you wouldn't. So, okay. I'm going to give it to you. Oh, hold on. One other type. Hold on. I'm going to give you one that's nasty. I'll give you a candy bar. You get this one right. Quiet, please. I want the 10th term. All right, so here's what you do. I need you to understand something. Let me give you an easy one just so you can see. 5, 10, 20, 40. I need you to see what you actually are doing and that you didn't even really realize it. You can look at this and go, what's actually the common ratio here? You look at it and you see that it's 2. You recognize that. Do you know how you got that? You did it by doing this. From here to here, you take the second number and you put it over the first. That makes 10 over 5. Here, from here to here, you take the second number and you put it over the first, which is 20 over 10. You take the second number and put it over the first, that is 40 over 20. And you look at that and you see, what's the common ratio here? 2. Does that make sense? That's what you do. That's how you find the common ratio. You usually can just look at it and go, oh, I see, it's 2, it's obvious. Sometimes, like the one that I gave you, you look at that and go, what's the common ratio? Well, it doesn't even look like there is a common ratio, does there? It doesn't look like it. Here's the deal. You take the second number and you put it over the first, which is 48 over 72. You take the second number and you put it over the first, which is 32 over 48. You know what those reduce to? 2/3. So that's the common ratio, is 2/3. You take the second number and put it over the first. And all you have to do is look at this. Sladen, it can't be 1.5, because if it was 1.5, what is 72 times 1.5? That would be a much bigger number, wouldn't it? Yeah, but we don't divide by 1.5. What is divide by 1.5?
48.
Dividing by 1.5 is the same as dividing by 3 halves. Do you agree? Dividing by 3 halves. We don't divide by anything. It's always multiplication. So divide by 3 halves is the same as multiply by 2/3, right? Right? Makes sense? So, since that's the common ratio, what do we have to do then? You take a to the, what? 10 equals a1, which is, why am I hearing talking? A to the 10. A1 is 72 times, R, what's the common ratio? 2/3 times 10 to the negative minus 1, so which is 9. 2/3 to the 9th power. All you do is you go, what's 2 to the 9th power? What's 2 to the 9th power?
512.
Over, what's 3 to the 9th power?
19,690.
And we multiply that by 72 over 1. What is 512 times 72?
33.
What is it?
30,672.
36,800.
I got 3,672.
I got
Oh, it's
36,864.
I did 51. Oh yeah, 36. Where's my candy bar?
You wish.
When I got it. Come on. Mr. Duncan, where's my candy bar?
Does that make sense? Guys, does it make sense?
Yeah.
Okay. Your homework.
When you divided, I got it the same thing as divided.
Right. But you can't possibly do the actual formula,
I didn't use the formula.
then you have to use the formula. See, that's the
I didn't
thing.
see how to use the formula.
You're right, you don't have to. You don't have to, except now from now on, whenever it says like the 8th term, I'm going to make it be the 80th term. 80th. Good luck dividing that and not using the formula, buddy. Good luck not using the formula. Yeah, right. Page 581.
I can't read your mind.
Okay, there you go. There's your homework.